This project is sponsored by PCBWay. They have sold the services you need to create your project at the best price, whether it's a school project or complex professional project. On PCBWay you can share your experiences or get inspiration for your next project. They also provide completed surface mount SMT PCB assembly service at the best price and ISO 9001 quality control. Visit www.pcbway.com for more services. Hello, self-balancing robot is a device that can balance itself from falling to the ground. Its function is to maintain balance using the motor's axis movement of wheels and body. There are several types of self-balancing robots, and in this particular case I will present you a way to make a two-wheeled balancing robot. Actually, I made this robot together with one of my students, and it is a high school graduation project. Although this is the simplest type of balancing robot and only requires a few components to build. First, let's explain the components used and their functions. MPU 6050 accelerometer and gyroscope sensor with micro electromechanical systems technology, that called MEMS technology, which is used to detect an angle and tilt of inclination along the X, Y and Z axis. The information from this sensor is transmitted to a microcontroller board, and in our case it is an Arduino Uno. This board is the brain of the robot, processes the sensor data and determines the actions needed to keep the robot upright. Processed data from the Arduino is sent to the motor driver board, which in our case is the L298N type. A motor driver circuit controls the direction and speed of the motors. This robot uses two DC motors, each connect to a wheel. These motors adjust the speed of the wheel to correct the robot's tilt. And finally a power source, specifically two lithium batteries connected in series, which provides energy to the motors and electronics. All components are mounted on a suitable supporting structure made of 5 mm thick PVC board. Now comes the fun part, which is customizing the code specifically for our built device. Depending on the layout of components, the center of gravity of the robot changes, and also each MPU 6050 board has minimal differences that need to be compensated for in part of the code. In the double set point line, we need to put a value that depends on our device. This is that line. To obtain this value, we need to hold the robot in ideal vertical position, perpendicular to the surface, and read the required value on the serial monitor. As we see in my case, that is about 182. If we look at the code in more detail, we will see that there is a place where the gyro offset is set. In this part of code, errors are corrected during the manufacturing of the MPU 6050 chip. For each individual chip, these values are different. Their value is determined using Arduino code made especially for this purpose, and you can download it at the end of this text. This is that code. With uploaded gyro offset code, with the uploaded gyro offset correct code, we put the robot in steady vertical position. And then run the serial monitor and wait for results. This may take up to 1 minute or more. Calculating offsets. And these are calculated gyro offset values for our MPU 6050 chips. We need these values in the code. Finally, we need to experimentally determine the values of Kp, Kd and Ki needed for bit control. For this purpose, we set all these values to 0. Now we put some value for Kp and perform testing. Too little Kp will make robot to fall over. Too much Kp will make the robot go back and forth widely, and good Kp will make the robot go slightly back and forth. Next, we need to set the Kd parameter. A good Kd value will lessen the oscillation until the robot is almost steady and will keep the robot standing. Lastly, we need to set the Ki. The correct Ki value will shorten the time it takes for the robot to stabilize. Now let's see what this looks like in reality. I want to emphasize that the surface needs to be raw enough to increase the friction between it and the wheels. And finally, a short conclusion. This is a relatively simple, visually effective balancing robot project that only requires three components to make. However, its setup, although it can be time consuming, is still a lot of fun trying to get the robot to stand steady on its own feet. Just to mention again that we created this project together with my students as a final high school exam.